Hi everybody, good afternoon, and thank you very much for joining this, the last of the six digital transformation series 2020 on modern methods of construction. And first of all, I'd really like to thank the sponsors, the Platinum event sponsor of Diatech, and then our Gold event sponsors who are Digital Construction Technologies, i3PT, Gravisoft, SIS and Celebri. Thank you very much everybody for your support. Next slide, please, Shannon. Thank you. And here we have the agenda today, and I'm really excited about this. It's going to be a really fantastic conversation. Each of our speakers has 20 minutes. If there's time at the end of each talk, we can have a little Q&A, but there is time set aside at the end for Q&A. So if you want to add your questions into the chat, that would be fantastic, and we can pull those up at the end of the session. But really, we're going to go on a journey today. We're going to hear from Chris Tisdale, who's going to tell us about the innovation integration and how we cross that chasm from innovation into actual reality and how we really disrupt the industry. And then we're going to get Josh, who's going to talk to us about the supply chain and disruption in the construction industry. And then Podrick's going to give us real life examples, as with Platt and as with Amy, on like modern methods of construction in practice. So without further ado, I'd like to welcome our very first speaker, who's Chris Tisdale. He's the founder and CEO of Ruckus Innovation Consulting, and Chris will introduce himself and present for 20 minutes. Thank you, Chris.
Thank you, everybody. Good afternoon, world, or as we say here in Texas, howdy, y'all. Hopefully the screen will be popping up in just a second here. Today, what I'd like to do is talk about innovation relatively in general in our industry and really have a call to arms at the end. I want you to try to innovate like your future depends on it, because it does. As we know, anything and everything can happen, and 2020 is the perfect example of being punched right in the face globally and being able to get back up again. And our industry across the globe has been seen as significant, probably more so than in the last 50 to 100 years. Construction across the U.S., I know, MIA and many other places, APAC as well, really didn't slow down. It might have had a bit of a hiccup in March and April, but beyond that, design and construction has been on fire, and there's a reason for that. It's because our entire industry, or all of the sub-industries that make it up, are incredibly impactful. So typically what I do is really get into a company, get into a firm, work with a number of designers, engineers, contractors, and a ton of owners, startups and mature companies. And really what I do, and it's the name of my company, Start a Ruckus. I love to pick a fight. I love to pick a fight with the status quo. I love to pick a fight with those things that are in our way and just punch right through them. And I do it with cowboy boots on, and I do it with a lot of great people like you on this WebEx today, and have fun doing it. It's not about a fist fight with each other, but it is definitely about a fist fight with all the junk that gets in our way. And let me start out first by just giving you my definition of innovation. It's really the art of fighting the status quo. And the status quo is not our history. It's not what made us. It's not what got us here. It's what holds us down and holds us back from tomorrow. I'm not even talking about 50 or 100 years into the future. I'm talking about tomorrow, starting tomorrow, getting tomorrow, being excellent tomorrow. And this fighting of the status quo is all about bringing something new or different. And even new or different has some nuances to it. It can be incremental, it can be disruptive, but really it's about scaling into the real world and hopefully for all of us creating a significant impact. So I'm going to break this down just a little bit during our talk today. So what is fighting the status quo? My hope is that you're doing this at a little bit or a lot each and every day and knocking the absolute you-know-what out of the status quo that's standing in your way. And a lot of what that status quo looks like is, quote, same old thinking, same old results. You know, the definition of insanity is doing the same thing over and over and over again and expecting a different result. Well, this might sound trite, it might sound, obvious, but this is what we run into every day. This is what fights us every day. And again, I don't want to say that the history of what got us here is the problem. It's not. I'll talk a little bit later on about what we should have taken from history and we should be doing with excellence today, and we didn't, and that's part of our problem. So it's not just me saying this, one guy sitting in Texas trying to stir up trouble. John Chambers, former CEO of Cisco, is basically saying, 40 to 50% of Fortune 500 companies will not exist in a decade. There's a reason for that, and it's not COVID. It's what we've been doing, it's what's been going on, and it's what's going to happen to these companies, whether they like it or not, in the next 10 years. 60% of startups won't exist in a decade that we're looking at today, that we're really excited about today, that we think is the end-all be-all of today. And then you have, one of our own, Brendan Bechtel, CEO of Bechtel, and many of you have heard him say this, our house is on fire. From an industry standpoint, we're losing in so many ways. We're losing good people. We're losing efficiency on projects. We're losing schedule. Frankly, we're losing money. And the reason for that is, to be honest with you, not all of us. It's the things that we keep thinking we're supposed to do in order to do something different. And it's like quicksand. It just keeps bringing us down and down and down. And I'm begging you to fight that. What does it look like, when we're fighting these inefficiencies? Well, take just seven of the Fortune 500 engineering and construction companies across the Dow in the U.S. You're talking about just 1.8% of a huge number, 77 billion in revenue, but 1.8%. Why can't we go crazy and try to get 2, or why can't we go even more crazy and try to get 5 or 6 or 10% of that? I mean, the margins that we're okay with is insane. And of those 7 Fortune 500 E&Cs, 40% of their projects make 310% of their profits. 60% of those projects only break even, or they actually lose profits. What are we doing if 60% of what we do on a daily basis just breaks even or loses? And 40% of all of these projects, the projects you're in, the projects I'm in, have contract costs that are transitional. They're contract costs, they're insurance costs, they're costs of dumbing down the information from a BIM saturated model down to 2D drawings and then back up again. I mean, it's somewhat ridiculous, and we don't see these types of numbers and these metrics hitting us each day in the face, but we feel these metrics every day hitting us in our projects. And if you look at a broader view of our industry versus all other industries, this is just a snapshot, a 5-year snapshot of the Dow Jones. We are incredibly valuable. We know we're valuable. During COVID, we're in the same breath as the medical industry in value. But when you look across, 2013 to 2018, the Dow Jones jumped 70%, and our industry, heavy industrial construction, dropped by 4%. Why? What are we doing? We can make a lot of excuses here on what was going on in 2013 and 2018, but you can't say that the Dow Jones jumped 70% and we dropped 4%, because we're doing some innovative work here. And the other thing that we're fighting here is assumptions. How many of us have been on conferences like this where we've been punched in the face yet again with this ridiculous 1964 to 2012, CAGR around our productivity dropping? The numbers are based in 1964, and here we sit in 2020. I'm asking you to just quit worrying about that. Just don't worry about what happened in 1964. Worry about what happens tomorrow, 2020, and get off our collective you-know-what and go start fighting that fight. This assumption that we're an antiquated industry is ridiculous, and we don't need to believe that. We need to believe in what the future holds, and I think you'll hear a lot of that from the rest of the speakers today as well. We're also fighting time. As of 2020, our industry collectively, at least in the US, is around 44, 45 years old. And if you look at our our colleagues in the EPC world, engineering, procurement, and construction, that average age is more like 55 years old. I want you to think about that for a second. In the AEC world and the EPC world, in 10 to 20 years, 1 to 2 decades, we lose most of the knowledge that we have today and how we design and build. To be really honest with you, that's both an opportunity and it should scare the heck out of you. Plus, we're fighting culture on a daily basis. At the very least, people are telling us to stay put versus do not change. And at the very worst, they're telling to slow the you-know-what down. And I'm begging you to fight through that. I'm telling you, put up your fists, put up your dukes, walk right through that. Don't listen to that. We need to speed up. We need to go faster. And this is not about throwing more warm bodies at a project. It's not about trying to, kill ourselves. I'm still talking about integrating. I'm talking about innovating. I'm talking about adoption of all these things that are in front of us, all these tools, all these procedures, all these processes. Adopt them faster, do better work, and do it quickly. And when I say new and different in my definition of innovation, what do I really mean? I mean, is there anything really new or different? And I'll talk about that in a minute, but every day is the future. You hear a ton on conferences and LinkedIn and a lot of talking heads, not frankly unlike myself here, who say, look to the future. I'm a futurist. We're going to be on different worlds in 100 years from now, and it's going to be all great. I'm asking you to look just to tomorrow, just to the next day, just a week ahead, just a month ahead, just a year ahead, because every day is the future, and I want you to take advantage of that. But having said that, let's for a second just look backwards, just for a second. 1833 to 2017, does anybody, especially in the home building arena, see much different across the world? Whether you're sitting in Austin, Texas, where you're sitting in Dublin, Ireland, frankly, whether you're sitting in Doha, even though there's some crazy things going on there. But the secret truth is, the real innovative truth is that we had construction manufacturing in the early 1900s. Where is it today? We're incredibly excited about companies like Katera at $1 billion+ valuation and all of these other companies that are doing, quote, construction manufacturing now. And we're super excited about it. I'm super excited about it. But for God's sake, why haven't we been doing this for the last 100 years? I'm trying to defuse the fear factor of change for all of us today in 2020, because to be honest with you, we aren't necessarily inventing. We're trying to scale, we're trying to adopt what has been here, what has been at our grasp for 100 years, and we've been afraid to do it. Modular construction. I'm a huge fan of modular construction. I've created and spun out a couple of smaller modular construction startups. I am the poster child for let's go modular. What's crazy is we've had this since 1940, 1950. Amy and many others on this know this perfectly well. We're super excited about it in 2020. This is the latest and greatest innovation, but it's really not. We've had it for 50 years. Why in the hell have we not been doing this for the last 50 years and been doing it excellently in 2020? I'm telling you to fight through the assumptions that we've been making for many, many years and start adopting the innovations and the inventions that we have at hand and we've had for many years. We're super excited in the construction industry for sure about exoskeletons, but exoskeletons, weren't just invented in 1965, they were viable in 1965 and have been ever since. And so all of these things that we think are scary and new and full of change today in 2020 have actually been here. We just haven't been told about them, or we haven't been shown them, or we haven't been allowed to pull them onto a project. And I'm begging you to break through those barriers and tell everybody, look, we're not inventing anything right now. We're adopting. We're going forward. We're taking all of this great history that we've had and we're actually making it viable. Industrial robots, in the manufacturing sense, aren't just for putting together a Volkswagen or a BMW. It's for putting together a building today, tomorrow, the next day. 1950, for 50 years we've had this. And for some reason, we want to pretend that we're unlike everybody else and we can't use those innovative tools. By God, we can and we should, and we know how to do these things, and we should put those in our arsenal and innovate like crazy starting tomorrow. Even construction robotics. This is a huge field that is going to make, I think, a huge difference in the way we design, let alone the way we construct. But this photo with Kennedy on the left-hand side is not a photoshopped photo. He's strolling past, viable construction robots in the 60s, and here we are today, getting super excited about something that has been around for 40, 50 years. But for some reason, we've been fearful of pulling it onto our industry platform, pulling it onto our job site, pulling it into our designs. And I'm telling you, there's nothing to fear here. This is all good. This is all innovation. This is all opportunity. Having said all of that, how do we scale all of this into our world now? It's not that we haven't had it. We've had it, and we've got it today. Now, how do we scale it into the world that we go through? Well, sort of like I've been talking about, this innovation continuum that we've been on since the dawn of time, everything that we have today that we think is required, the cell phones, the cars, the PPE, the processes, the procedures, all of those things, whether it was a document or an artifact, was impossible at some point. Some crazy person jumped out there and did something, some kind of prototype, some kind of silly thing, and it looked impractical, and we laughed at them and we pointed at them, frankly. But then a spark of genius showed up in each of us, and we thought, well, maybe it's possible. And then we said, wait, it's not only possible, I want it. We should have that. That's genius, right? And then it became scaled and required. And I'm asking you to jump into that. Everything should be expected. We should expect everything, to be honest with you. We should go after everything. We should have everything because we can. We're smart enough. We can do this thing. We can innovate the heck out of our industry and expect everything that you want can happen, can come to fruition, and it can be required. Scaling this innovation is really important. And I'll give you the one secret word to scale across every industry, let alone ours, is experiment. And this is the one thing that I think our industry is really, really loath to adopt. And it's the one thing that has held us back for 50 to 100 years. And that's experiment. We're so worried that we're going to spend money on things that don't work. And we're so worried about failing fast or frankly failing at all. And I'm telling you, if you look back at those data points from Bechtel and others in our industry, we are already failing. And we're only failing because we're trying to squeeze the same circular object into the same square peg over and over and over. We should be experimenting on a daily basis, small, medium, and large, across the system. We should be trying to innovate everything that we do, everything that we touch, everything that we look at, not just selfishly for ourselves, but every individual, every colleague, every friend, every loved one in our industry that we're working with. And we can do experiments for no money, hardly any people, hardly any effort, all the way up to lots of money, throw a bunch of people at it, and spend a lot of effort on it. I don't care how you do it. I just want you to try something tomorrow as an experiment to try to make your life and your colleagues' life and our industry's life better. Experiment, experiment, experiment. And how else do we scale? Well, one of the things that's really important for all of us to look at, and we don't necessarily take this incredibly seriously, and that's our workforce. 2020 has the most diverse workforce that we've seen throughout our industry. The baby boomers are starting to leave. There's just remnants, to be honest with you, and maybe those baby boomers are sitting in the C-suite, but even those baby boomers in the C-suite probably have 10 more years until they retire and go fishing. Gen X, my generation, we were one of the smallest generations across history. There's not a lot of us to begin with, and we only make up roughly 20% of our workforce. But the millennials, Gen Y, they're already 50% of the workforce, and this is pretty much a global number at this point. We need to be looking at how we nurture, how we engage, how we innovate with, how we educate millennials, and frankly, how we attract that huge workforce base into our industry. Because I'm telling you right now, from the colleges, from the technical universities, from industry, incubators, they're not coming to our industry because we don't look and we don't sound and we don't talk innovatively. Yet we produce the built world on a daily basis. Then, of course, there's Gen Z that's coming, and alphas themselves, which if any of you have children 0 to 7 years old, you now have an alpha in the household that alphabet has turned over again and started over. Alphas, we could spend hours just talking about alphas and what will happen in the future and what they look like and how different they are from, frankly, any other generation before them. And I don't say that lightly, and I don't say that in jest. There are some incredible things coming in our future from a generational perspective with alphas. And not only, scale across people and who we work with, but also scale across actual speed and time. I mean, think about 50 million users, how long it took us to get 50 million users across any of these technologies. And I won't go through all of them, but airlines, 68 years, television, 22 years, computers, 14 years. Look at Facebook, had 50 million users in 3 years, Twitter in 2 years. Pokemon Go, a game, had 19 days, had 50 million users. Please don't tell me that our industry, any one of your companies, can't somehow garner 50 million users by tomorrow, because there are absolutely ways to do that. And then how do we scale, competitively? Well, first of all, I think looking at who your competitors really are. And if you think that another architect, another engineer, another contractor are really your competitor, I want you to look much, much broader than that. These brands, at least today, 2020, these are your competitors. The largest contractor on the planet is sitting in China, and they're worth about $70 billion. That falls just behind Walmart. Any one of and that's the largest in our industry. The largest architect, I believe, globally is Gensler at about $1.6 billion. They're not even on the chart here, no offense to them. If you don't think that one of these companies can come knock on your door and change your entire industry, let alone just change your entire company, you are kidding yourself. And this isn't even, and these aren't even the 800-pound gorilla. The $600 billion pound gorilla in the room is this brand. And if you don't think Tesla is disrupting your industry already, you are absolutely kidding yourself. So really understanding how we scale our business compared to who our real competitors are. And our real competitors are data competitors. They're competitors that are looking across at a platform perspective, not a project perspective. This is really where we need to be looking at. Factory integration into the job site. IoT across our industry by 2035. All of these things are going to integrate and interconnect. And finally, what is all of this mean? A significant impact that you are bringing to our industry. By 2050, 10 billion of us are going to be on the planet, 7 billion of us in the built environment that all of you design and create, creating, a demand of 2x energy. We collectively are building buildings at 1,000 per day, and that number will only go up. The spend on what we do is only going to go up. Trillions and trillions of dollars in infrastructure. We're 6% of the global GDP demand. And then you've got regional demands around and requirements, and Ireland is in this as well, just as the United States is in EMEA and APAC. But you look at MEA, and they're talking about printing 25% of the buildings across their region by 2030, and that's nothing. Our own U.S. government, whether you love them or hate them, has basically put a flag not in the sand on planet Earth, but in the sand on Mars. We're talking about inhabiting Mars by 2030. And even if you think that's silly, even if you don't believe that's going to happen, putting a flag that far out and failing gloriously is going to put us and our industry so far ahead of where we are today that it's going to have a huge significant impact. So my call to arms here is get in the ring and innovate everything, question everything. Look at what you're doing and try to make it not just a little bit better, but in a crazy, crazy, crazy amount better. Finally, please, if there's any questions or follow-up or anything like that, please hit me up at any of these sites. You can find me anywhere. And finally, go punch today in the face and really enjoy the rest of the speakers. And I know Claire's smiling at me and looking at me because I'm sure I've run over at this point. Thank you so very much. And I hope at the very least you've got, this sort of, you got your juices flowing for today for the rest of the speakers, and you got that fighting spirit. Thank you very much. I appreciate it.
That's brilliant, Chris. What an opener. Thank you so much. That was really inspiring. And so without further ado, I'd like to pass the baton now to Josh Johnson, who's an expert in engineering, construction and building materials for McKinsey. And I'm really looking forward to your talk, Josh. So the floor is yours. Thank you.
Thank you. And good morning in this case from Philadelphia. It's a pleasure to be here. Give me a moment. Let me share my screen. So I really appreciated a lot of the points that Chris made. And I think that, when we kind of talk through what some of the disruptions are likely to be when we look at offsite construction, many of them come from, this adoption and dogged holding of the status quo. So it's going to be a good opportunity to kind of tie some threads between the previous talk and hopefully the conversation that we're having today. So a bit of a commercial before we begin. I'm from McKinsey & Company. We're a global management consulting firm, and we actually do a lot of thinking and work in the construction space. So we've published several different pieces of knowledge on the construction industry, modular construction, building materials, etc., all of which are free. You can just go straight to mckinsey.com and download the entire thing, download several copies of it, share it, read it, put your coffee on it. And most of the work that I'll be discussing today is based on, if not one or all of those perspectives. Specifically, we'll be looking at the last two that we published this year. So the next normal in construction and then modular construction from projects to products. Again, both of them are available for free on our website. So to put a point on some things that Chris said, construction is massive. If you think about construction as a national economy, construction would be the third largest nation state in the world, behind the US and behind China. It was $13 trillion, I believe, of spend in 2019, right? So this is just an absolutely massive industry, which is critical to the global economy, right? And I won't belabor this point because Chris talked about it pretty eloquently during his talk. But there are some pretty significant outcomes and dynamics that drag us down as an industry. So when we think about the construction industry overall, it's a really fragmented industry. We're talking globally here. Everyone works on a project-based approach. There are generally misaligned contractual structures and incentives. There's a lot of use of temporary contractors and staff. And then when you think about it, and I think this is a contributor to some of this risk aversion in the industry is, a general contractor, a big general contractor is in many instances not necessarily executing, i.e. hands on hammers, a project, but they're managing the project and managing the risk around the project. And so you've gone from people actually at the highest level investing in truly building the asset outside of the technical expertise and the project management expertise to people managing the risk around the building of the project. And when you're a risk manager, you are naturally much more conservative than you are if you're not a risk manager, if your entire business hinges upon your ability to manage out risk, right? So where does that get us? Lagging productivity growth, we've talked about that previously. Slow innovation and digitization, low profits. I know Chris quoted a number around 1.8% on average globally. We're looking at 4 or 5%. So that's not as bad as 1.8, but that's still, nothing to write home about. And then low customer satisfaction overall. Budgets and schedules are routinely overrun. And so what does that mean in the context of COVID-19, right? We did a survey back in May to understand, what the industry was doing related to the global pandemic. And nearly 70% of respondents believed that COVID-19 is going to accelerate investment in technologies and facilities. And that was mirrored, by the way, only by this thought that they were going to also invest in the control and value chain and industrial grade supply chains, right? So what do we mean by industrial grade supply chains? Right now, if you're a general contractor or working in the construction space, chances are you work on a project by project basis. You sign a deal with an owner. 6 to 12 months later, you're calling your suppliers for the materials for that project. You are either putting those materials down in a laydown yard, or perhaps there's some one offsite warehouse that you're storing your consumables at. You've phased the really big stuff in so that it gets built and shipped to site on time. And then you build that project. When we say industrial grade supply chains, we're talking more about, Volkswagen, Ford, even Tesla, Microsoft, these Dell, Intel, supply chains that span multiple projects, that span multiple geographies, and that leverage the heft and breadth of your organization across multiple projects in this instance, to drive up your efficiencies and drive down your overall material and supply chain costs. And so this value chain control and integration with industrial grade supply chains, excuse me, is a main push that we see, and also kind of accelerated due to the global pandemic that we're currently in. And it's not just people prognosticating about it. When we asked that same panel of CXOs, because of this shift, has your company increased investments in these areas? An analogous amount of respondents said, yeah, we're spending money in technology and facilities. Yes, we are putting down the capital to improve our control of the value chain and boost our capability in our supply chain management. So, this is a talk mainly about, where do we see some of the disruptions happening based on supply chain, how offsite's going to do that. But, the fact of the matter is, again, to some points that were brought up by Chris, a lot of this stuff has been done in the past and is being done. Industrial engineer. I grew up in manufacturing, and the archetype that you would categorize a construction company under is a job shop. I come to you and say, Construction Co., build me this project, and you build me a snowflake, and then I go off. And if I went to a different construction company, they would, within reason of the physics of the project, build it slightly differently or plan it slightly differently, right? You're going to shift from that model of job shops to scale producers. People, you don't go to, your car dealership, whether it's Peugeot or Ford or any other one, and say, I'd like a car. And unless you're spending a lot of money, right, and getting, you get like a specialized, handmade, very unique car to you. No, you go and there's a brand or a make and a model that you're looking for, and outside of some very specific trim choices, you're getting like the scale industrially produced version of that car. Finally, when you look at the next normal, what's it going to do to the value chain? Well, we think these disruptions are going to be significant. 40 to 45% of the value at stake is going to shift in most affected segments. And so what does that mean? That means if you think about the construction industry on a continuum, all the way back from design and engineering through execution, and you look at each of those different chunks, you have your designers, your engineers, your architects, you have contractors, you have your material suppliers, etc. That each of those groups has a certain piece of the pie. Well, we think those cuts of the pie are going to shift rather drastically, and a lot of those cuts are going to consolidate a bit in offsite manufacturing and which is going and technology, which is pushing a lot of this productization and industrialization of these construction projects. So what does that look like practically? Digitized, industrialized with new operating models. So a more consolidated value chain, as opposed to now where, you know, an owner has an RFP out and, you know, goes through several phases of feed or front end engineering and design before you're going and actually, you know, choosing a contracting partner and executing. You're going to see developers choose entire designs or specific components of designs from a suite of options, as opposed to starting everything from scratch. You're going to see more consolidated value chains, especially in manufacturing, for that are internationalized. You're going to see more digital sales channels for developers and suppliers, and you're going to see a lot of the project setup and financing around it being much more transparent on cost, on deliverables, on project tracking, progress tracking, and scheduling. When you think about manufacturers of materials and components and equipment, you're going to see a lot more integration of those components, and this is what Amy refers to more as your prefabrication, as opposed to your volumetric modular forms of modularization, right? You're going to see many trades, and this is happening right now again, but you're going to see it in a much larger scaled version. Many different trades combined into different building materials, or multiple steps combined into one building material. The industry itself for offsite manufacturing and will shift from, you know, several job shops to construction projects being productized, specialized, and branded. And you see this even now with some of the companies that, you know, we're looking at as the darlings of the industry, or the avant-garde, the front end of what's happening in the construction industry. So it's not going to be generalist construction company. It will be, you know, Josh's Roads, you know, Chris's Houses, you know, Shannon's Office Co. And there will be brands of construction projects, end-to-end building products that you will see moving forward. And so because that shift will go from job shop to integrated manufacturing, suddenly supply chain and logistics coordination will become the fulcrum among where competitors win or lose. Currently, it's project management. Again, risk management. How do I get my project from start to finish, spending the least amount of money, exposing myself to the least amount of risk, and getting it done, you know, as close to schedule as possible. Now it's going to be, how do I coordinate? In the future, it will be, how do I coordinate all of the disparate, you know, materials and people to my production facilities, and then coordinate those production facilities to produce at tact, to then deliver the subcomponents and materials that I need for each of my different production facilities on site, i.e. the construction projects as we think of them now, right? When we look at the buildings of the future, those buildings are going to start to need to be optimized for total cost of ownership with IoT sensors for sustainability. And then again, on this piece around robotics, you know, there's no doubt in my mind, and again, you know, Chris touched on this before, that, you know, robotics is not new. Robotics is going to be something that you will see increasingly on the job site for several reasons, chief among them being the labor shortage that we see internationally, and second among them being the fact that, you know, we're not seeing a massive influx of people yet into the industry. You know, and then finally, when you look at contracting and execution, you know, the contractors and the folks on site, you know, are going to need to be able to produce a project at a much higher level of productivity, with, you know, what you would consider the buzzword lean construction, execution, and assembly, specialized and focused on site at a much higher degree than we are right now. So let's look at a couple of case studies about like how this is actually happening, you know, right now. You know, we made the statement, you know, developers choosing entire designs or specific components to digital marketplace as well. In a sense, that's happening right now. There's, I picked a random manufacturer on the platform, so there's no focus here specifically on CEMEX. There are lots of different building material suppliers here, but NBS Chorus and NBS Source are effectively, enabling you through BIM objects to choose and specify the specific building material and supplier in some cases, way back in the design and specification phase of a project. So you have architects that are literally saying, I want CEMEX, dry silo mortar in the masonry that is going to go in this area of my project right now. There are also, through NBS Source, and again, this is just an example, NBS Source literally enables them to then say, all right, I'm now going to go to that manufacturer or that building material supplier and source the materials earlier. And so you're seeing a couple of things. You're seeing the developers, shift this procurement function earlier in the process by leveraging building information models and BIM objects. And then you're also seeing the rise of these digital marketplaces, as opposed to needing to go through, either a general contractor or even a distributor. You're able to specify these things and then access them digitally. Developers will contract with one turnkey supplier. The market kind of global poster child for this is CitA, but there are some other players, most notably in the UK, Top Hat, that are also following this model, where they own the production of the building end to end, all the way through from architecture, design, and engineering through execution. And while these are newer models, these are by far, these are not the last two players to try to adopt this model to now put you're building a CitA real estate or a multifamily real estate asset, or you're building a Top Hat single family home, right? A branded project, as opposed to, Joe's Construction built this single family house somewhere and it's just, the bespoke project that they built. Supply chain projects, project management as the primary coordination challenge. This is an example, I believe from 2019 over in England, where Mace Group built factories on top of two high rises in Stratford. And literally had to manage the supply chain to bring the building materials onto the factories, subassemble all of the different components in these factories, and then do the fit out in each of those stories. And they were able to complete 18 stories in 18 weeks without raising the cost of execution. You talk about, Chris's point around innovation, we're talking about offsite construction. This is about as close to on-site and off-site thing could be. When you think about, crews working over each other in phases, or your MEP crew on top of your finishing crew. Here, they literally put a factory on top of the structure. We're able to subassemble and top of your finishing crew. Here, they literally put a factory on top of the structure. We're able to subassemble and productize, or subassemble and modularize each of the fit out components for each of these floors, and simply ferry them where they needed to go and put them in place. And talking about moonshots, their goal is to be manufacturing, not constructing, but manufacturing 85% of their projects 50% faster, in 2 years from where we're talking right now, via just-in-time logistics and sharper site management embedded by technology. So it's not about simply project management. Are my subs on time? Do I have the materials in my laydown yard? It's about managing the logistics, the supply chain, as the fulcrum of your productivity and your profitability, rather than your ability to manage that risk. And then finally, when you look at, just different, and this is a more of a volumetric look, but when you look at, different kind of business models, even in volumetric modular, that cover the construction value chain, you have all of these different types of modular, volumetric modular players, also expanding beyond just building the module itself. You have, your Top Hats and CitA that do everything, and then you have other players that will simply that will simply take larger chunks of the value chain. So those are the topics that I have to cover right now. I see Claire with my warning. So I'll stop here. If there were any questions and I had time, I'll take them. If not, then we can move forward.
Yeah, if we could hold questions just till the Q&A, just in the interest of time, that'd be great, Josh. But that was
awesome.
Fabulous. Thank you so much. Really, really interesting. And so again, without further ado, I'll pass on to Podrick King, who's the design manager in King & Moffat, to take us through how using technology to facilitate offsite and modular MEP installations. And Podrick, I'll let you introduce yourself. Thank you. The mic is yours.
How's it going, everybody? My name is Podrick King. My current role with King & Moffat Building Services, I'm the design manager. I was the BIM manager with the company from 2016 to 2019. I went back to college in 2016 and completed a 2-year HDIP in building information modeling. I had a big interest in it at the time. I still do. I think it's at the moment it's definitely a key driver towards offsite and modular construction within the company. And I successfully completed multiple large-scale BIM Level 2 M&E projects in Ireland, in the UK and Europe. Just a brief overview of the company. It's an international company. We're currently on site in Ireland, the UK, Germany, and the Netherlands. We're pricing work in the Nordic countries. And we have international clients such as Amazon, Lidl, and Hilton Foods. And our M&E team, they're familiar with local standards and regs in the various countries and regions where we undertake work. Just there on the right-hand side, on the map, we've completed projects in all the navy colored companies, and we're targeting projects in the orange. Our company turnover in the last 2 years, the company turnover has actually it has over doubled, and we started doing a lot more mechanical. Primarily, we were doing a lot of electrical work, and we now have a full mechanical division, which is a lot of the reason for the turnover have gone up so much. And we've targeted new markets in places like Germany and Holland. So our main office is in Carrick-on-Shannon, and we've got 4 offices in the UK. We have 1 in Germany and 1 in the Netherlands. So I'm going to talk to you today briefly about offsite and modular MEP installations. So I was really enjoying what Chris and Josh were saying there, and it's kind of more it's the kind of next level when you come to huge companies altogether. But unfortunately, at the moment, we find ourselves, we're working for different clients who have different specifications, who want different materials installed on their projects and in different countries, which means different regulations, different specifications, different types of cable you can use, switchgear you can use. So it's very hard to standardize everything when you're working across so many different countries. So we're trying to streamline some of the work we're doing by moving it off-site. And just at the end, I'm just going to quickly talk about some of the benefits that we've realized from using modular and off-site construction. So why we've done it. So one of the key reasons is the travel costs, the carbon footprint. The fact that we're doing a lot of work in the UK and Germany and Holland means there's a lot of flying, there's a lot of traveling. And if you see there on the right-hand side, flights really they do increase your carbon footprint. And so especially during the COVID pandemic, there was a good few months this year where we had people going to work and they had no choice, only travel on their own in vans and cars. So again, to travel up to site to do the work rather than maybe come to a facility close to home where you didn't have to travel as much, and all the social distancing and everything could be done a lot easier. So the COVID-19 has opened our eyes even more to this. So another reason that we started looking at was the delivery issues. We find that doing some of the work off-site, it's really eliminating issues that we've been having with deliveries of material to site. So deliveries from wholesalers, they usually never arrive when they're promised that they'll arrive. So you could have a team on site, go up and install brackets, and then cable ladder might arrive a couple of days later, and then basket mightn't be there for your ELV stuff, so that might arrive a couple of days later. So what's happening is people are returning to the same location on a construction site on numerous occasions to try and finish one task. So just that image on the right-hand side, we'll talk about it later on, but it's basically everything is arriving all at the same time. All the supports, the hangers, end caps, 4 and sometimes 5 different types of containment. So when that stuff is brought up on the mupes and cherry pickers and fixed onto the structure, that it only has to be visited once. Everything has been put up in one go. So there's no going back there again. Another reason we were looking at it is a lot of the projects that we're working on, they're suitable. The suit modular and off-site kind of methods of construction, kind of large scale logistics centres, warehouses and food processing facilities. They can be long linear M&E service runs with minimal change over the course of a full run. So that image on the right, that particular building, it's 0.5 kilometre long. So if you can come up with a method of repeating a certain run of services there and building them off site, you're on to a winner. Again, modular lighting systems and cable containment systems and pipe systems, they're very suitable for this. We've noticed that there's an increase in safety because you're undertaking all the work in a controlled environment, and you're eliminating things like weather-related dangers that can be associated with a construction site. If buildings aren't sealed, you have wind or frost or maybe other trip hazards, and then falling from height accidents. You're taking all of those out of the mix. There's less competing with other trades for workspace when an area becomes available. So what I mean by that is sometimes when you're a subcontractor on site, like mechanical and electrical, you might have sprinkler, or you might have refrigeration. You could have people putting in white wall and trying to get drop rods in, but you could be waiting for a concrete slab to be poured. And what's happening then is everybody's racing into the same corner of a facility, trying to get their services in. So it's increasing danger and it's less productive. The most suitable tools for the tasks as well they're kind of permanently installed in a fixed location in an off-site facility, and all the PPE is there beside them. And you have dedicated workstations for assembly and cutting. So maybe rather than cutting supports with a battery-powered angle grinder, you have a dedicated saws that can cut through full bales of unistrut, maybe 50 lengths in less than a minute. So again, it's saving time and it's safer work. Project programs and handover dates. So these programs and the dates we have to hand over buildings it's getting tighter and tighter every year. What's happening is we can notice we're getting into the jobs later, but the handover dates aren't changing. So sometimes we'd have weeks to get in and do a full install for a client with the main contractor and have to hand everything over. So having the prefabricated M&E service modules ready for dispatch, it reduces the installation time on site, and we can be building those while things like the structure is going up, the concrete is being poured, the building is getting sealed, and then as soon as the team on site are ready, we can have them on site within a day or two. If the job's in Ireland, it's within a day. If the job's in the UK or Germany, you can have it on site within 2 days. But instead of having to start everything from scratch on site, when the area becomes available, you're really speeding up the time on site by doing this. And all of the M&E modules, they're pre-assembled, so they need to be lifted into position then and just connected to the structural elements. So it's really reducing the amount of time we have to keep people on site. So just going to talk about how we started doing it. We haven't been doing it for a very long time, but we've made a big investment in Carrick and Shannon in the Midlands in Ireland to an off-site facility. We've requalified electricians and plumbers and fabricators, welders working in there at the moment, and it's a sector of the business that we're hoping to grow in a large scale over the next 6 to 12 months. And from this facility, we're delivering out modular and off-site solutions to our live projects in the UK, in Europe, and in Ireland. And we're noticing that it's improving the speed and the safety and the quality, and it's reducing our carbon footprint. And just a couple of images there on the right of the facility and some of the stuff we're doing out there. So I think coordination is the key to success when you're an M&E subcontractor. I think without this, you're taking on huge risk, because you could go to site and having to do it off site and having to do it again on site, you're really starting to lose time and money. So for a new build, I think the coordination with the other stakeholders is key, and we use BIM to coordinate with other stakeholders on a project. We really try to have fully clash-free models before we start any work on site, or before we commit to building MEP modules off-site as well, because it's a huge risk for any company to take if it's a thing that you get to site and realize, well, this contractor hasn't been delivered in BIM, but because of the regulations in this country, they can't move. They have to be in that position. You'll have to move this duct, or you'll have to move these pipes, or you'll have to move this cable containment. So that's why having a coordinated first off, it's key for us. And I think it's vital that everybody has bought into this whole process from the beginning of the project. For any existing buildings, we go in and laser scan them. Just a very short video here that will show a bit of the process, but I think after doing this, you have an exact representation of what's on site. So again, it allows you to move forward with confidence. Okay, so basically that video was if we were going into an existing project and it's not a BIM project and there's no 3D models available, but we still want to try and do as much as we can off-site. We go in to get a real picture of what it is, we laser scan it, and then can bring that back. That gives us a point cloud, build a model of the point cloud, and then we're able to coordinate all our services, supports, our main routes and spines of services within the building, and we know when we arrive to site that it's all going to work. So we also use BIM to take out all of the information, so there's no manual takeoffs or no manual counting because we use BIM. After we've built all the brackets, we're able to take everything out of a schedule straight out of Revit on the right-hand side, and that can go straight over to offsite. We've actually developed this further in the last couple of months, and we'll slide on that later on. And when we can get, basically we can get all of our stuff to site in time, and it's right first time when we do this process. Another thing that we can quickly check the stock levels and offsite before sending module information over. So before we send the details of a linear run of the modules, the MEP modules over to offsite, we can quickly send them information from a schedule out of Revit, and they can check if they have enough stock for all the different types of supports, whether it be pipework, cable ladder, data basket, and they very quickly can kind of establish, right, we need to order more of this because there's a delivery coming at the moment and the modules are going to contain this. So A big focus is on combining the M&E services and the modules that we send out to site, because we send a team out, and if the brackets if brackets or modules are put up, we just think it's very pointless to have another team to go out and do the exact same thing for the mechanical element if someone's after going up and doing it for the electrical element. So sharing bracketry, doing all the load calculations and the structure, and getting them approved before you install them on site is very important. By doing that, you're saving time and money, and you're eliminating double jobbing that's associated with it. For designing skids, the first thing we do is we check that they'll fit where we're proposing to fit them. We're using BIM to develop up all our skid designs, and what that's doing is it's basically means our fabricators don't have to go around and start manually measuring or doing any takeoffs. All of their pipe cuts are basically contained on a drawing that we'll send over to them. So again, it's just reducing the chance of human error, and it's saving time when everything is sent to offsite. There's no manual takeoffs or manual measurements needed if you use the BIM. And you can do everything with confidence. That's what I feel when you have that reassurance. And again, if any kind of linear modular systems we're doing, we feel again, if you're after going to the effort of building it up in your Revit model, use the power of BIM to give you the automatic. It can give you back all this information out in a schedule. So that's an important step. Another thing I'd advise is if you can standardize where possible. So just typically on a project, you might have, these are distribution boards. So your cables out to your lights, your sockets, all of these things come back to a distribution board, which looks like basically this on the screen. You can have an 8-way, 12-way, 16-way and a 24-way, but we've standardized it to 12 and 24s, and we've bought them in bulk into the facility. So even if an 8-way would suffice for a certain project, we don't do that. It's basically 12 ways, and they can be pre-assembled and ready to take straight off the shelf and start putting up all the trunking around them and prepared to be sent out to site. This is something on site that takes a lot of time. It's hard to get it looking right, and a lot of the time the containment that's surrounding those distribution boards, the wrong 90-degree bends can arrive to site. They're a specialist type. So again, that eliminates all the time and labor you could lose on site again by doing this. And again, standardizing it, if we're doing up supports for any of our M&E installations, we basically have in our template on the left-hand side of the screen there, you'll see we only, all our BIM coordinators only have these to choose from. So this automatically puts it into a schedule, and that whole naming convention. It's something that the guys don't even need to draw on for over and off-site. Exactly what's required, and the information on what part of a structure you're fixing to is all contained within this. So it's totally automated. If a BIM coordinator goes and just starts adding all the bracketry for the services, they don't even need to think about doing anything else. When it's done, this schedule can go to off-site, and within a day it can be ready for shipping out to site. So again, standardizing and automation. There's probably a lot of people going to be talking about it today. I'd love if we could do more of it, but I still believe with the different specs and regulations and clients and main contractors, it's quite difficult at the moment. If you're getting into the offsite, try and look at solutions that are easier to ship and transport. So you have your wire suspension systems there instead of threaded rods. They're way easier to transport. They take up a lot less space, and you're eliminating hotworks on site. If they need to move up and down on a hanger there, you don't need to cut them with angle grinders. Transportation, and almost finished here now. I see Claire is coming up here as well. Just as a quick example, again, on the left, from left to right, you have 86 cantilever brackets in the first package. In the second package, you have 500 2-meter struts with 5-meter wire suspensions in the next pallet over. So that'll just give you an idea, if you're using wire systems, how much space and time you can save, and again, reducing the hotworks when you hit the site. Modular lighting systems, again, you just hang them up, plug in your lights. Each one of them doesn't have to be wired separately. You can take the light fitting off them without plunging a full circuit into darkness. There's greater flexibility if a client wants to move them in future. They're not fixed. And just a couple of the benefits very quickly, and that's me finished, everybody. Huge savings on travel costs and wasted time associated with travel, reducing the carbon footprint. Safety benefits like the controlled environment and the suitable cutting and drilling and grinding stuff, workstations and tools there full time. It's helping us with programs on site. We have way better control now of when everything is arriving to site, and there's less time required to install it on site. It's eliminating a lot of paperwork that is associated with RAMs and hotworks permits. Saving on labour costs, so the site team aren't standing around waiting to get access into an area of a project. Saving on material costs, because it's exact ordering of materials, and we're buying in bulk into one location now as well, and there's a saving associated with that. And it's made a lot of our elements of our workflow at the moment much more lean. And main contractors and clients love to see it. And we're just going to continue to push this aspect of the business over the next 12 months.
That's brilliant. Thank you so much. That's excellent. Thank you so much, Ulrich. That's fantastic.
Cheers.
And so our next speaker is Platt Boyd, who's from the CEO of Branch Technologies, and he's going to give us a really very interesting talk on 3D printing within the industry. So Platt, without further ado, I'll hand over to you. Thank you.
Good morning. Good afternoon, actually.
You should be able to take control of this screen, I think. If you stop sharing, Ulrich, that'd be great. Fantastic.
Can you see that?
Yes, yes, thank you.
Okay, very good. So good afternoon, good morning, depending on which side of the earth you're on. So Branch is a prefabrication company making commercial facades. And we use construction scale 3D printing and robots to make those walls. So my name is Platt Boyd. I've been in construction for 21 years and practiced as an architect for 15 of those. But even as a partner at a firm doing $200 million worth of projects, everything was a box. So something like this costs $1,500 to $2,000 a square foot. And that's a problem. That's not accessible. That wasn't accessible to me at my firm, and is not accessible to the majority of people on Earth. So how do you make something like that, a dream, become a reality? Well, you have to get something, what you see here, into normal budget. And so asking the question, how might we be able to build things like that and make a better way to make buildings? So it's been encouraging to hear a lot of people preaching about this and some of the problems about construction that have been around for a while. All of us are aware of that. And we know that there are some inherent problems in construction. We also know that it's an enormous market. It's $11 trillion globally, but I would posit with no real innovation. And what I mean by that is that we're still building with post and beam methods of construction from millennia ago. So what I'm going to do is start by asking a couple questions. So we all know that construction is not industrialized, and it's one of the few remaining markets that are not industrialized. So first question, what if you could industrialize construction? Talking to most general contractors and subcontractors, asking them what their number one problem would be, most of them would say that finding qualified people. And so they can't really find the qualified people, and so the ones that are out there, they have to incent through higher pay. And so we have this rising labor cost, and we're overspending on that labor. So second question, what if you could galvanize a new workforce and bring in some of these millennials or Gen Zs? We've seen this chart many, many times. That labor that we're spending a lot on is not really productive when compared to manufacturing. So the third question, what if you could double or triple your productivity? And then the way that we make things is we take a huge chunk of earth from one place to another. We harvest it, we move it, refine it, process it, productize it, then we warehouse it, ship it to a site, and then that bespoke building, we take that component that's a given size, we cut and carve out of it for that custom building, and then we throw the remainder in another big pile. So what waste? So next question, what if you could only use the material necessary to build custom buildings? And then last question, what we've seen in the computer and the ability to create for the last 20 years is almost impossible with traditional methods of construction. And it's this digital divide. So what if you could make that impossibility a possibility? And it's encouraging to hear McKinsey on this call. I've been following some of the work that they've done. They have a really deep dive that they did several years ago called Reinventing Construction. They identified 7 different drivers to the future of construction, and we're addressing 5 of those. So those big problems are beginning to drive innovation in a very old and conservative market. So our approach is a bit different. We use large-scale 3D printing, but instead of a layer-by-layer approach, we use a unit geometry of a cell. And so it's a process called cellular fabrication. And hopefully this video will play smoothly. But our software creates the internal geometry and sequences a custom path plan for a large-scale industrial robot. And we're using freeform 3D printing that we've developed, where material solidifies in open space. And what you're seeing is using 20 times less material than a solid print process. And in this case, it's carbon fiber reinforced polymer, where a 2-pound block can support 3,000 pounds. We take that kind of skeletal structure and fill it with fire-rated commercial grade spray foam, and then we mill that down robotically to get to the custom surface finish. And now instead of 3,000 pounds, that same block can support 6,000 to 10,000 pounds depending on the density of those cells. And that's about 3 to 4 times the strength of normal wall framing methods. So this is direct digital manufacturing. And we start with that 3D model, and then it flows through our software stack. And what we digitally produce and sell are those custom components that can take on almost any shape. Those are then shipped to the job site and fit together like big Legos on site. So what we're making right now are these prefabricated next generation wall systems. It's a custom facade for a commercial building, and it's creating that signature identity. It attaches back to the structure of the building and becomes the outer skin. So these panels, they're lightweight, they're strong, they're fast to install, and they have 10 times the design freedom of traditional methods. So you can see here some of the finishes. We call it branch clad. The one finish on the left is glass fiber reinforced concrete, and then this on the right is a lightweight synthetic stucco. So technically it's a ventilated rain screen that is outboard of the weather barrier of the building, and it's hanging on just the traditional carriage system for rain screen. So those panels hang on that carriage system. So what this is doing is taking something that would be like a very, very boring kind of office park. Like this was an example project that somebody asked us to take a look at as a really boring 80s office park, and we showed what could be done by applying different patterns to that skin. And what this is really doing is creating signature identity. and especially in COVID, where we all have to set ourselves apart in some way to survive, this gives that ability to distinguish from just all the boring boxes. So a couple examples. This one is installing now. We're based in Chattanooga, Tennessee, in the southeast of the US. So this is here in Chattanooga. It's a bank. And so our design team created several different schemes and showing what some of the digital possibilities were. The client selected this one because it emulated their logo and kind of waved across the facade. And so this has now been prefabricated and it's going on site now. This is another project for a parking deck for the city of Huntsville. Our design team created several different schemes. The client chose this one, and this is working with Turner Construction, who won the bid for this project. And this is, the parking deck is under construction right now. We actually put into fabrication this week the panels, which will start installation in March of next year. And then another project, this is for a museum that's space related and using different themes that you could see having to do with rocketry or places that you might go. What we did is we took a scan of the moon and literally put that onto the facade of the building. And so when people come up to this building, they'll see the texture of the moon on the surface of that facade. And then working with a design build team, going after an RFP, we created 3 different schemes for a parking deck that was local here to Chattanooga, based on things that are thematic here. And so like rivers, mountains, and outdoor environments where the interweaving limbs of trees come together. And so our team selected this one to move forward with, and that's what it ended up presenting like at the final presentation. Our team won that solicitation, and so that's under construction right now. And then another example for a mixed-use urban environment outside of New York. This was for the podium level of a much larger development, and a couple different options. So those are all in that facade and what we're calling branch clad. Another category of product that prior to COVID was pretty hot was called digital rock work. And so this is something where that's a very manual on-site carving concrete process right now in the theme environment. And so what we were doing is taking that very articulated surface and then digitally doing that. And you can see some of the articulation that you can get with that digital rock work. And things that are, I mean, that's a 7-foot tall panel. I think that weighed about 30 pounds. And so that's the beginning point for something that typically would be about 3,000 pounds. And then those pieces come together as components and make larger assemblies. Our foundational and beginning product several years ago that we introduced was I call it the Matrix, but we've kind of branded it a little bit differently now, calling it C-Form. And so this was a pavilion, several pavilions for Art Basel in Miami. And at the time, they were the largest 3D printed pavilions in the world. And they were located there for this exhibit for a week, moved to downtown Miami where they were for 2 years. And while they were there in downtown Miami, they went through 3 different hurricanes. So that's a significant test for an early stage company, but they survived and they did well. And then they're now on their 3rd life. And one of those pavilions is in Nairobi last summer for a UN event. And another interior installation, this was for a natural history museum in downtown Chicago, and they call this nature clouds. And so it's hanging hydroponic gardens with feeding mechanisms that can raise and lower to create different environmental effects for that huge space with lighting and sound, and it also regulates the humidity in that space. And then a project that we were approached by a developer a couple years ago for a band shell in Nashville, Tennessee, where music is big. And so this was a performance space. And now this is where the Nashville Shakespeare Festival has their outdoor performances. And so this is a 42-foot span from side to side, 21 feet tall. And originally when this design was created, it was $500,000 of steel. And so by using strength created with geometry, we were able to take out all of the steel on this project, other than the base plates, and use the 3D printed structure to span that full width. And so that became the largest 3D printed structure in the world 2 years ago when we installed that. And then a demonstration project that is finished on the printing side. This was for a house, a design competition that we sponsored to show what the future of construction can look like. And so this is really exciting to see what different designers, when they have new tools, what they can create with those. So this is something that does not come about just by just popping out with an idea one day. There's over 100 person years behind this, a very cross-disciplinary team coming from construction, software, robotics, industrial design, and many different industries, and some really amazing places to make this possible. And then a lot of IP behind this. These are the awarded patents thus far. But one of the things that we've had to do is validate all this, because it is new, and get code officials comfortable where we put these different projects. And so a lot of testing and certification, because every project that we've ever done has had to meet international building code for where it's located. These projects oftentimes are the first of their type in the world, and so they garner a lot of press. And so we've received the benefit of that. And so that's been a great thing that I'm very thankful for. And working with some amazing partners and clients over the years, and then backers that have been a part of this. And I'm thankful to say, I mean, I started this about 7 years ago, and back then there was very, very little investment money focused on construction tech. I'm thankful, and you're really the first people to hear about it because it gets announced today, is that we closed a new round of funding led by a construction tech company called Equipment Share. And so we're excited for this next chapter that opens up. So you guys are familiar with prefab and all of the benefits that brings to the table when you're off-site construction. So predictable time, predictable budget, factory level quality and efficiency. Well, this brings all of that, and then the inherent customization that 3D printing brings to the table. And so instead of it looking like a cookie cutter box, every single thing can be custom. So it's the marriage of those two capabilities. And the way in which we work is really a turnkey relationship. So on the design, on the engineering, fabrication, and then coordinating with the local install team. So in the end, what this is doing is looking at, for general contractors on an RFP, that's something that it's setting it apart from all of the other competitors, and meaning that you can win greater amounts of work. From an architect and design standpoint, this gives abilities to break out of the box and do things that they win design awards. So that's how architects get additional projects. And ultimately for the clients, it's creating that distinctive identity that gains exposure, foot traffic, and customers. And so what we say is that those custom structures create unfair competitive advantage. So in this, really, we're going kind of prehistoric and then post-digital, looking at how we are made and how the world around us is made on a cellular level. And we're all familiar with this. The bounds of a cell create some strength, but it's really the material filling that cell that provides the majority of the strength and function for that assembly. So we're using minimal amounts of 3D printing to create that, and using it for its benefits, not its novelty. And those small unit geometries can be modulated to create strength where needed. And then the filling provides the strength and function of normal wall assemblies. It's digital craft. It's the marriage of a person and a machine in a complementary relationship, and asking how do we take advantage of the things best suited to each. So those big problems that I brought up in the very beginning, how do we solve those big problems?
1 minute left, Black Platt.
Okay.
Thank you.
So first, you have to ask the right question. And then start with first principles to solve those. Like, how is something made? It's made on a cellular level. How can you produce things digitally? Using robots. What materials can conform to those various geometries? Morphable materials. How do you control that process using software? And then how do you produce that efficiently in a factory? So it's not reinventing the wheel, it's just thinking differently about a very old problem. So someone recently asked me when construction would have its transistor moment. And what they meant was integrated circuits were brought about 70 years ago, and it enabled the digital processing of information. And that's revolutionized all of our lives. So this is digital making. It's the digital processing of matter. And we believe that the implications are generational. It's solving those big problems that I brought up in the beginning, bringing industrialization, productivity, a new workforce, material stewardship, and digital possibility to the construction arena for really one of the first times. And the outcome is amazing buildings that bring greater value to our clients. And so let's see what we can create together.
Fabulous. Thank you, Platt. That was excellent. I'm sure there's a ton of questions for you, but we'll leave those until after Amy's spoken. And Amy, I'm going to give you your full 20 minutes. Don't worry. Thank you, Platt. Amy, so yeah, we can see your slides, Amy. Thank you very much. So delighted to have Amy talk to us now. Amy's the head of industrialized construction strategy and evangelism in Autodesk. So Amy, the stage is yours. Thank you.
Thank you so much. Super excited. The speakers are great. This is interesting today for me. I have to be honest. I have something to say about what everyone's talking about. So I grew up in the construction business. I've traveled the world. I've worked on 6 of the 7 continents, not just as a consultant, but also as a constructor, fabricator, assembly consultant, working in lots of big places. I don't know if it's so much about a change in thinking. I'm going to get to that, Platt. I heard you say that at the end. I think we all know there are new things out there, everybody. I want to talk a little bit about what we can do now to make this happen. And I think first I want to level set on some language. Thanks, Josh. I love some of the amendments you've made to your language since we spoke. Josh is a friend of mine. He's great. I hope you guys really enjoyed what they're doing over there at McKinsey. So I love that Josh showed the example of Mace. And also we've got stuff like that from BAM going on in your area where they're doing prefabrication on site. And so offsite really just denotes location-specific prefab at this point. I hear all these words sometimes mixed up like a word salad, whether it's offsite or prefab or skids or modular, industrialized construction, modern methods of construction. I want to do some level setting before we go on to not just change in thinking, but also change in action. So I used to use modern methods of construction. Some of you guys know I run actually a page on LinkedIn that's called Modern Methods of Construction, MMC. I didn't always love that term. I felt like the second I said the words modern, it felt old. If you've ever said 21st century technology, it's like you want to stop yourself. It just sounded old to me. And so I've been using for now industrialized construction. If you're an architect on here right now, you are not excluded from this. I know industrialized construction sounds like we're focused only on the physicality, but it's really the application of manufacturing techniques to the built environment in totality. So in conceptualization, design, pre-construction, construction, fabrication, assembly, on-site, all the way through operate. And I think you need to understand that I want to do things better, right? We've all talked about, I think it's funny, we all say we need to be more like manufacturers. And then we walk out of these presentations and everyone turns to their friend and said, what's a manufacturer? You know, it's like we know that, we don't really know how to be a manufacturer, but I want to take some baby steps and we can talk a little bit about what that looks like. So industrialized construction for me is that umbrella term. Let's take it from the bottom up of the foundation. I'm a lean manufacturing person, so I love the house that Toyota built. This is sort of my rendition of the house that industrialized construction built. There at the bottom there are enablers, both process and technology enablers. We've talked a little bit about IoT and what that building looks like in the future that can be responsive and talk to us and tell us what it needs. I think that's really important. Big data and analytics, we're a big data company, data-driven company at Autodesk. We're seeing more and more of that be important. I think we have a real problem with data in our ecosystem. When you continually design and fabricate and install snowflakes, one-offs, it's real hard to get consistency in the data. And I forgot who talked about it, but we all know we're not doing so well on bringing things in on time and on budget. Even typical big capital projects, there's a lot of big studies out there that they are typically late and over budget. Even the best projects ever, people to note, are also late and over budget. But in order to get good data, we got to come together on what that data needs to be like and what we want it to be. And also I hear the words data and I think data means one thing to some people and another. That's a whole nother presentation though on the language of data. Then there's the cloud. If you went through COVID and you didn't recognize that getting your information up into the cloud, being able to access it, to work at home, work offsite, being able to do that, you missed something here, right? So the Autodesk Construction Cloud, we've had lots of clients come to us in the last, since COVID started, that would be unable to work if everything they had was really on their desktop. So it's great to move everything to be more resilient if we can. Process enablers, actually BIM, I could kind of move in between technology and process, to be honest. Multi-dimensional CAD drawings enable us to see models that we can actually coordinate better. Lean manufacturing, I'm saying that on purpose. Lean construction doesn't necessarily get you prefabrication and industrialized construction. The tools are very trade-centric at the moment. We have to start thinking element-centric on the elements on the continuum. And then design for manufacturing and assembly does not mean prefab. I feel like in Europe, you guys love to say it as if it means prefab. It's actually an enabling methodology that gets you prefab downstream. And if you truly understand DFMA, you'll have optimized prefabrication downstream. It's real hard to assemble construction and stick-built design. That's what you should think about. You move up to the physicality of the prefabrication continuum. Again, I like to think of prefabrication as the terminology. You have on-site prefabrication and off-site prefabrication. Advanced building products, materials that reduce drying time, curing time, welding time, that hot work, anything that you can buy from a manufacturer that gets better flow on the job site. They're usually slightly more expensive than their not so smart counterparts, but you're not looking at the first cost of the material. You're really thinking about flow for the job site, removing labor from the job site. And single trade assemblies, that makes sense, right? To you guys, electrical whips, could be pipe spools, could be light gauge frame panels, or even a precast wall. Multi-trade assembly, again, self-explanatory. There are both volumetric and non-volumetric multi-trade assemblies, but that's where really all the action is at lately. And then you get to volumetric modular. They are not in a hierarchy on purpose. Volumetric modular is not the best application, neither is single or multi-trade, right? They are not mutually exclusive. They are a toolkit of parts, and you use the best one for the right application. Sometimes using volumetric mods is like shipping very expensive air, and that's hard. So we want to think about pieces and parts. We want to think about this continuum as a toolkit. And you can create those pieces and parts by using things like robotics and automation and additive manufacturing. Those are not the only ways to do it, but we've all seen some examples of that. And this is not an exhaustive list, this house that industrialized construction built, but it gives you a pretty good understanding. I won't go too much into this because Josh obviously did an amazing job. My only thing, and I love that even Josh recognizes and somebody else on the panel, it's that we're talking about what the next 15 years might look like. And I believe that it's been happening already. I know McKinsey does as well. But if you haven't read that book, Who Moved My Cheese, now's the time. There's very little cheese left in our ecosystem. So if you haven't adjusted your internal processes, your learning, your tools, your training, your culture to understand that this is changing, it's not a journey anymore. It's a race. And you may not be in the race right now if you haven't made some adjustments to what you're doing now. So it's like a vice is on our ecosystem. And I say ecosystem on purpose because we're not an industry. We are an ecosystem of lots of different industries. You've got those big serial owners people are talking about in the chat, and they're asking for this. They're kind of tired of having big programs over multiple geos that have no consistency in cost and schedule when they know that they need operational consistency. One of my best serial owners actually uses the phrase, I'll take certainty over savings every time. So we have governments that are requiring it and incentivizing it. I've worked with the government of Singapore for many years and lots of other places that are really asking for three things: digitization, prefabrication, industrialized construction, and decarbonization. You'll see that even more as COVID has continued. But we have a lot of global proof points. You can't go anywhere without seeing a front page story, mostly, unfortunately, about volumetric modular, because it's kind of sexy, I think. But we've got subcontractors, specifically the MEP subcontractors like Mr. King over there, who've been recognizing the value of prefabrication for many years. And we've got some I personally don't put my money on the quirky, even if they have multiple billions of dollars they've saved. I don't put my money on the ones that, are telling us we're doing it all wrong and they're the answer. Or one little quirky company that has been doing, even my old company that did volumetric modules for over 80 years. At the end of the day, this is a very entrenched ecosystem, and it's got lots of different silos that have been interacting with each other for hundreds of years. But what those companies do for us is they show us a vision of the future. And I'm not saying they won't be here in the future, but I think you'll see a lot more of this players that have been in the space actually coming up and either buying some of those companies, adopting their methodologies, or just showcasing some of the stuff they've already been doing like Patrick did. And we're in a global economy, so there's lower barriers to adoption. But what's happening to some of our siloed players? The general contractors are getting squeezed. They may or may not know how to integrate some of these pieces and parts. Most of them have actually started buying factories so they could sort of take over the silo next to them. And then you have architects and engineers. Aside from some of the investments you just heard about, they're also buying fab shops. They want to design and fab because they are also trying to figure out the value proposition of what the new normal looks like. Then you have COVID, and it's squeezing us even harder, right? You've got to change. There's a lot of pressure. If you don't feel that now, you're probably not going to be here. You're just a little bit numb potentially. So what does that mean for us? Well, it's one thing to say we've got to change our thinking. We've got to do this stuff. We've got to actually move the information of make, which is manufacture and construct, and operate, which are things like carbon and life cycle of these materials and what we're going to do for them for the environment later. You got to move all that information digitally up into design. That's called DFMA. Currently, our only solution is you should bring me up into the front of the process and I'll teach you how to work with my prefabricated element. Well, I'm 49. I'm sort of tired of getting to the front of the process where I have to speak out what I need and for DFMA principles. I would rather teach the computer with machine learning and AI to take all the information of these products and pick the right ones together, and also take what I'm doing and optimize that because it's much smarter than I am. Again, I'm kind of old here, but we're not using the technology that already exists in things like generative design and computational design and an enabled connected platform to really do this correctly. And it's not like anything needs to be invented. So just let me tell you that. I like to tell the story. One of my friends said they tried to go digital on all of their contracts. And for 3 years, he was struggling with that. It's a friend of mine who's a mechanical contractor. He said 3 days after COVID, somehow they got that done. And I was like, look, new technology wasn't invented when COVID happened. We're just treating it differently. We're behaving and interacting with that differently. Just want to let you guys know that, right? So anyway, change your behavior and thought process, but behavior is more important, right? So I'm going to go on and say DFMA, just to give you a quick, this is like super flash track. DFMA doesn't mean prefab, like I said. We're not making up words here. It comes from manufacturing. So DFM, design for manufacture, are design choices you make as an engineer or designer that optimize the manufacturing process. So you'd have to understand the supply chain that supports that manufacturing process, the details and the way in which they make things, the flow of the factory, what makes sense, how they're going to be making these pieces and parts. And then you combine that with DFA, which is design for assembly, which is how the choices you make are going to make it easier to ship, handle, assemble, put in place, and get these pieces and parts on site in an accelerated method. You would have to understand, how do I pick it? How do I transport it? How am I moving it? How does it get fastened? For each and every one of those elements, right? We've concatenated those two terms to be called DFMA. And so what are we really trying to do? We're trying to shorten design cycle times and fabrication cycle times, and also installation cycle times, just shorten our cycle times in general. We talked a little bit about, somebody didn't say this word, but they talked about concurrency, doing things while you're doing things on site. That helps too. But we want to reduce material and overhead and labor costs, and we want to create better standards to reduce cost. Listen to that thing, standards to reduce cost. But these are all enabled and optimized through the design choices, and they are both generic DFMA principles and some that are very element specific. So these are the generic ones that I teach. We're not going to go into them today too often, but design it once and use it many times, right, is one of them. Those are easy. Here's where it gets hard. There are element specific instructions that you need to understand from the person making it. And so if you multiply just the 55 instructions that go along with this precast wall panel, and then you multiply it by the number of other pieces in that building, and then you multiply those by the number of proprietary systems that could potentially exist on this planet to use, it would make any architect's head explode, right? So we can't keep doing this by hand. I used to own my own company, and I've traveled the world doing this, teaching these processes, but in reality, we've got to move to technology to enable this, which is, most of my friends didn't understand why I came to Autodesk. When I explained it this way, they were like, wow, that makes perfect sense. The only way I could actually make impact on the space anymore is by coming here to Autodesk, where we can actually create some change. So prefabrication is more than just these boxes. I want to leave you for sure with that. And by the way, we hear a lot of stuff about housing and hotels, but in reality, where all the money is spent right now, the big money is in all of these places where there's heavy MEP integration. By the way, the mechanical contractors I know are like the most humble, nicest guys in the world. This has been going on for about 25 years. They've been fabbing. And it's all those places behind the walls, underground, above the ceiling, in the central utility, where it's been going on all along, whether the architect or engineer or even the general contractor recognized it or not. These guys have been fabbing for a few decades because it's the only way that they could survive, by getting more and more productive and safer, by the way. So this is where we should really be focusing some of our efforts, because not just the future, but in the US, there was a study that said 2/3 of general contractors and 3/4 of trade contractors report experience in the past 3 years, now 4 years, with MEP multi-trade assemblies. It's becoming standard practice for intensive projects. That's not 15 years from now, that's now. Right? So the MEP trades, I believe, and some of the structure guys are actually leading the charge, for the record. So what's our strategy now that we know that? So I came here to make a difference at Autodesk, and here's what we're going to do. First, we need to make DFMA and prefabrication easier. We can't keep leaving it in the hands of people like me that are aging out of the space and wanting to retire soon, right? So we've got to embed that and connect the Autodesk platform with this IC ecosystem. Now, Autodesk platform doesn't just mean our software. It's a platform that has our product portfolio in it and enables partners and other people's software to interact, so we can get connectivity of the real discrete data that's going to help us be very functional. And we need to create a collaborative IC community so that my friends don't call me from around the world and ask me questions. When I retire, I want them to go to a place, and so do all my friends that are in this space. They want this learning to live in a place where you could stand on the shoulders of it and get better and better and better, where we're capturing it for people around the world. So that's important for me here at Autodesk as well. And so let's talk about productization for a minute. By the way, I said snowflakes. What do I mean by that? We will never get transformational in our ecosystem unless we start learning. And you can't learn when you do something for the first time every time, right? So think about when you've installed equipment on your factory floor. The first day you open it, you're not that productive. There's a learning curve to that. But most people right now are living in this initial ad hoc or repeatable phase. Even if they're doing prefabrication and doing DFMA, they are basically waiting to take drawings and then they're cutting them up in the way in which it's best to fabricate. We have very little productization, unlike when a generator is put up front to the process. And we know at Kohler or Cummins, you can have a 200, a 250, or a 300 horsepower generator. You can't say, hey, Cummins, can you make me a 217 and a half? They won't do that. We've yet to determine what these products look like, even though they could be products, right? And I don't mean, yes, the entirety of the building. Don't get scared, architects. I'm not saying everything should be gray and boxy and look the same. I just told you there's lots of things behind the walls, below the ground, above the ceiling, in the central utility plant, places that architects don't really even necessarily like to draw. I don't even know an architect that loves drawing fire stairs. If you're out there, raise your hand, come to me. But there's lots of products that can be utilized. If we define them, we can then manage and optimize them and use them in things like generative design and understand digital twin in a much more efficient manner so that we can really take advantage of technology. By the way, these have different pathways and patterns, these products. You can't use all the same software to understand the functionality of everything, but we need to connect them. And that's what I'm doing at Autodesk. I know this is hard for you. It's been hard for me too. I want to make it easier. I need help from my friends in industry, working with the big players like Autodesk and some of the big serial owners, those guys that want to keep building the same way over and over for operational consistency. And I'm creating some groups over there and some learning so that we can learn from each other to understand the pathway, the best one for an MEP product versus a precast product versus the light gauge product. They don't all have the same DNA. We have to truly understand the product, and we need to really define those, scope them, cost them, and know, and move them up front in the technology and the process, connecting the platform. And so, by the way, I think the future, I have a minute and 15 seconds left. I got to tell you about the future in a minute and 10 seconds now. We're very siloed. I just wrote a paper called Creative Destruction, Breaking Down Silos for the New Possible. And I don't think it's because we're not smart that we can't get this done. We're paying people in business silos to do work that is effort, not value. So it's like, okay, we all know sometimes people draw things later in the process, they get chucked in the bin and we redraw them. And then we have to move them back up and then coordinate those drawings. Why do we do that? Well, it's not because we're not smart. It's because somebody lives in a silo and gets paid to do that work, like they live in this other silo to get paid and redo that work. We have to stop that. Design and construct and manufacture is not going to look like this. It's going to look more like systems thinking. And so you'll see a lot of business model convergence, and everything needs to replicate this systems thinking and convergence. My ecosystem influencers are super important. Designers, you get to become empowered designers when you use technology to do the things that you don't necessarily want to do. And everyone becomes potentially systems integrators and making products, and we become platform providers. I always like to talk about my shoe. This shoe is an 8.5. I used to put my foot down on paper and they draw lines around my toes and call it my shoe. It's an 8.5 because I can get it now on an enabled connected platform, and we all know what an 8.5 looks like. And I can set the parameters so that I say I want a red leather shoe with a 4-inch heel from a 5-star manufacturer. And by the way, the software also says you should buy this shoe, this shirt, and this necklace, and this jacket. That's what we need. And we're going to get that in this ecosystem with your help. So start productizing. If you want to hear more about me and what I preach, because I think this is hugely important, or we will cease to exist on this planet as an ecosystem player anymore. That's really what I'm all about. So I think I've done it almost exactly at 20 minutes. I'm going to stop sharing and let some other people ask some questions. Thank you so much.
Amy, that was phenomenal. Thank you so much. Wow, what an event. Really, really good. I have a million questions, but before I jump in, Alan, are there any questions on the chat? I've been following and I haven't, if all the speakers could put their cameras on.
There's quite a few here, actually. I'll just come in
Is
here.
There?
I just put one in the chat there now to Amy. What do you think Autodesk is going to look like in 2030?
Wow, in 2030?
Yeah, you'll be retired by then.
I'm going to be retired. I know.
Yeah.
I think at the end of the day, the platform of Autodesk is a super powerful platform, right? Like, I've learned one thing, which is why I came to Autodesk. You can't get people to change both their behavior and their tech and their thinking all at the same time. It's just too hard. So I think it looks like a much more all-inclusive platform where we truly are connecting, like we are today, just more expansively, designers, makers, operators, and owners, and manufacturers. I think it looks a little bit more fluid in the sense of there's not so many siloed personas. I think we are more of a convergence, attentive customer and company and customers with us. Convergence is key in platform.
Yeah.
Fantastic.
I know one of our directors, Ralph Montague, has got maybe had some observations about some work by an economist, Marina Mazzucato. Ralph, do you want to come in there and make any comments about the speakers today?
Yeah, well, the comment was about innovation and where it should occur. I think a lot of people are looking at innovation in the actual construction process and the technology, but the observation by the economist was that 80% of the economy is actually tied up in financial insurance transactions and real estate transactions, and I was wondering if it's the same for construction. That means that only 20% of the cost of construction is actually going into building stuff, and 80% is tied up in the construction. So it would seem that we would need some innovation in the transactional piece. I just wondered if the speakers had any thoughts around that.
Yep, this is Josh Johnson here. So your typical capital project, I don't know the exact split, so I won't quote you a number, but I will say that it is not 80-20 in favor of the financing. If anything, the majority of the cost in your average capital project sits in materials and labor. The financing cost and the transactional costs are not negligible, but they're still, single percentage points of your overall capital project cost. I will say though that I agree that there need to be, there has to be innovation of the entire delivery model, including the financing and transactional costs. If you look at, your average capital project and how it gets costed in, the financing is directly related to the risk perception of the lender, right? And so as we continue to get more standardized, more repeatable projects and capability to execute those projects in that way, safer, on time, with better budgets, then the risk profile for some of these things goes down. The financing costs tend to get impacted there. It's similar that you'll need different ways of collaborating in the entire consortium of partners, both the financing partners, the design partners, the execution partners, et cetera, to actually execute this as well. So while yes, you do need to have impact on the transactional side of the capital project, it's not the majority of the spend, and two, focusing on kind of the execution piece will enable different models in that area, is what I would say.
By the way, don't miss what Josh just said at the very, very end, which is different models will enable new practices in those areas. You cannot get this done with the current risk profile and contracts and insurance programs that are out there, and the way in which we require bidding and the way in which we do design up front. You will never get this unless you change those first.
And one thing I'll add, Ralph, is when I was director at Construction Industry Institute, we had about 150 different members across AEC and EPC. We did a ton of research with those particular members. And if you look at a typical $100 million project, the minimum number of contracts that we could find on a $100 million project was about 400. So, I don't disagree at all with what Josh is saying, but the delta between where Josh's numbers and that higher number of 80% is if you delve into each one of those 400 contracts on a $100 million project and look at, quote, the 80% that is in that one contract, or even the 2% that is in that one contract, and you multiply that across the entire $100 million financial transaction that is XYZ project that we're trying to all, Amy's ecosystem model is trying to complete, right? I think that's where that number comes from. Even if it sounds conflated or inflated, every one of those contracts has some sort of inflation around labor numbers for insurance and financial costs, and it grows and grows and grows and grows. So at some point, the bill comes, right? We've had a $100 million big tasty meal, and that bill comes, and inside that bill is a huge amount of insurance and financial and real estate and labor cost inefficiencies that we are all paying for. And the one thing I'll say finally is that I think a fundamental key to innovation in our industry is going to be smart contracts and blockchain. And I know blockchain is one of those words that everybody goes, what are you talking about? And define it for me. And oh my God, Bitcoin and all this kind of stuff. It blows our minds, right? But I'm telling you that as we really understand and mature our industry around blockchain and look at smart ledger and look at smart contract transactions, it will absolutely open up a platform of data, of everything that Josh is talking about, everything that Patrick's talking about, Platt and Amy. I mean, it will be fundamentally the biggest change, I think, in our industry, allowing for a flood of new innovation, because we'll be able to capture at a very, very, very minute level all the financial transactions, and we will not have to worry about that. Now we can control data. Now we can innovate like crazy. So anyway, I'll shut up.
Maybe we all need to go on to Amy's LinkedIn page and just continue the conversation, because there's lots of discussions going on between speakers and delegates there today, and I don't think we've got time to do this.
I think there's one more, Alan. I'd like to ask Platt a question, actually. It's
yeah, sure.
So just around the circular economy, Platt, the question is, does this approach, 3D printing, new materials, etc., help or hinder the circular economy? How will we know in 40 years' time what can be reused or recycled?
Yeah, no, that's a great question. And it's something that we have. One of our core values is wise stewardship. And so that means using the minimal amount of material necessary to create something. And so the interesting thing on some of the projects that we've done is we've architected materials to perform for different characteristics that they needed on that project. And so one example was with NASA for a 3D printed habitat challenge. We had to use indigenous material to the moon or Mars and the simulant of that and recycled materials. And so we created something that approached the strength of concrete, where like a concrete cylinder that weighed 4 pounds that we printed in a polymer, it held 62,000 pounds in compression. And that's 2/3 the strength of concrete. So it was incredible how you can create a material for performance needed, but with materials and kind of designing that material. And so we're not really there yet as a company, but the day will exist when we can architect those materials to be completely circular. We're having to use off-the-shelf materials. And it's just, that's a nice to have, not a need to have at this point in time. But designing material, we've used a biopolymer that's biodegradable for that project in Chicago that I showed, the Nature Clouds project. And so that's another example of that.
Yeah, no, fantastic. And Sean's come back with another message there that we don't really have time for. So with that, I just want to say thank you all so much. And sorry, Porrick, I did have a question for you, but we're out of time. My question was around skills. But yeah, so thank you very much. And I'm going to hand over to Alan. That was really informative. And thank you all for sharing with us, because sharing, obviously, Amy, is the first step to all this collaboration. So thank you all so much for sharing your knowledge with us today. And with that, I'll hand back to Alan. Thank you.
Thank you very much, Claire. You did a great job as well, keeping us on time. And I might just ask Shannon just to share the final few slides, just to send some messages to you for the remaining of 2020 and our outlook for 21. So we could just go to the third slide. So yeah, absolutely, Claire. I thought it was a great event. The presentations were really excellent, world class, so inspirational. And you know, when I hear things like from the Irish government that major change is required in the industry to deliver faster pace, and we need to do this by finding out what people need and do a detailed needs of analysis. In some cases, companies don't know what they need. What we really need, I believe, is leadership in the world to show what the future holds, not ask people about what they're doing and what they need. So there needs to be more kind of foresight thinking. So I just want to reiterate where we are with the Alliance. Again, a fantastic lineup of speakers. Thank you to our sponsors. Just to remind people, that separately. That's the whole idea of the Construction IT Alliance, multidisciplinary, not in silos. Our focus also is to connect people to innovation, so that really sings what Chris is talking about. Innovation came up so much this afternoon. And we focus on building a membership, providing what we can with the small team we have and the funding that we have around events and research. We have a very active training network and SkillNet. We've outstripped all the targets this year with the CitA SkillNet training, I suppose, due to COVID. And next year, we're going to focus on the circular economy. Why the circular economy? I suppose it's very topical. We're going to continue with our tech trend events. We hope that other companies will come in maybe and help us. Maybe Autodesk might look at us next year. So we're going to talk about what is the circular economy, what does it mean to construction. We really want to get some leadership, demonstrate leadership across the world in regard to this area. So more about that. We're running out of time, but you know, it's about protecting the environment. It's about not using more natural resources. It's about new jobs. It's about reducing CO2 emissions. It's all of that, and hopefully coming out of COVID, as we all get our vaccines and we start to go back to a normal way of working. So I just want to wish you all my very best. Thank you, Claire. Wish you all a wonderful Christmas. And we're having a bit of fun over the next few weeks. We're going to have a quiz, and we're going to test people's knowledge of what we do and who's been speaking this year. And we have some prizes and so on. So I can't thank our speakers enough. You did a fantastic job. You know, we had over 50 speakers this year, and you know, I keep saying that every event gets better and better, but this was superb. You know, thank you so much. Yeah. And so take care and stay connected, and we'd love to see you at our events next year. And thank you to our delegates also, and to the team behind CitA, Suzanne, Elenia, Shannon, and for all the hard work, and Sam, that you don't see behind the scenes.
That was great. Thanks a million. Thanks very much.
Thank you, everyone.
Thank you.
Bye.
Take care.
Bye.
Thanks, Claire. You did a great job.
Thank you.